hello. My name is Pablo Sopelana, and I'm the founder and CEO of Navalapp, a learning platform dedicated to yacht design, naval architecture, and ocean engineering. At Navalapp, we are committed to advancing the marine industry through affordable, high-quality education that supports skill development, career growth, and innovation worldwide. We are proud to serve students from more than 80 countries, and our courses are also used by companies and institutions for professional development and continuous learning. I'm also here with Winston Pin. Welcome, Winston. Winston is an experienced naval architect with almost 3 decades working across business, technology, and education. He is currently the chair of the Naval Architecture Technology program at Memorial University's Maritime Institute in St. John's, Canada. And besides co-hosting today's conversation, Winston's also making sure everything behind the scenes, from the sound and video to recording and editing, runs smoothly. Today, we are really excited to welcome Dr. Peter van Oossanen, Peter for friends, a world-renowned naval architect and scientist whose work has had a huge impact on how modern yachts and ships are designed. Peter earned his master's and Ph.D. at Delft University of Technology and spent over 20 years at the Maritime Research Institute Netherlands. Back in the late 70s and early 80s, his research on yacht performance led him to the design team behind Australia 2, the yacht that made history by winning the 83 America's Cup, breaking the US 132-year winning streak. In 1992, he founded Van Oossanen Naval Architecture, a company known for performance and innovation in high-speed boats and advanced vessels. And over the years, Peter has published more than 100 papers, contributed to the Principles of Naval Architecture series, and earned multiple international awards for his contributions to the field. Since retiring, he's been channeling his lifetime of experience into the science of sailing, these books that I have here, an incredible multi-volume series that captures both the art and science of yacht design. Peter, it is a real pleasure to have you on board. Welcome.
Thank you. Thank you. It was a nice introduction.
We would like to start maybe from the beginning, maybe something about you, Peter. So when people ask what you do, how do you usually answer to that question?
It depends a little bit on who I'm talking to. But basically, I would say that I'm a naval architect first and foremost, turned author when I retired, and so an author at this stage. When I'm talking to people at MARIN, for example, when in a research community, I would answer and say, well, I'm basically a scientist turned naval architect turned author. Yeah, that's basically it. And the things that I do is I love writing. And as you've already memorized, I've written a series of books, both technical and not so long ago, I turned my hand at fiction, and that's keeping me very busy. But again, it's something I love doing, and I wouldn't know what to do with myself if I wasn't able to do that.
Yeah. Well, when you were saying that, I was thinking of this man of the Renaissance that he's focusing on many different things and all of them doing very well, so that you have a lot of different interests: science, writing, naval architecture, and many things. So this is quite interesting.
So Peter, this is my my first time meeting you. Of course, I've heard about you and I've read your papers and I've read about you, but it's the first time that I've actually spoken to you, and it was such a surprise to expect
yes.
a Dutchman and to hear the Australian accent come out. You know what I mean? So
don't match up.
Yeah. So
yeah.
And I've read that you did grow up in Australia, and of course you immigrated, I guess, returned to the Netherlands to go back to school, and I'd like you to talk about that a little bit. But you grew up in both Australia and the Netherlands, and so how did that mix of cultures and environment shape your outlook?
Well, let me first say that my family was one of hundreds of thousands that immigrated to Australia, Canada, and South Africa after the war, the big war, and it allowed me to grow up in Australia. And it wasn't until I was 21, when I was attending a lecture at the University of New South Wales in Australia, that I heard about the Delft University merits that sort of enticed me to go back to the Netherlands. But your question about the two cultures is hard to answer, but let me try. Australia is a laid-back country, but they're enormously free. Now, in Europe, as Pablo will say, life is very restricted and we have to adhere to very strict rules, if only, for example, the tax system, to mention just one thing. But it has its merits. I wouldn't say categorically that Australians are lazy, not by any means. There are many renowned scientists and people with a lot of inventions to their name that are Australian or New Zealanders. But it gives an additional perspective to what we have in Europe, and that is basically the relaxed atmosphere at which you can do your work. People here in this country, particularly that run small businesses, are complaining about the enormous amount of paperwork that you've got to get through to be able to run your business. In Australia, all you do is decide one day to run a business, and there you go. Of course, people will tell you that you need to become a member of a certain group of other people, but I found Australian life to be very appealing. And when I returned to the Netherlands, I met my wife to be, and if it wasn't for her objecting to me going back to Australia with her, I would probably have gone back to Australia. As it turned out, I'm very much a Dutchman. I don't know whether it answers your question, but it's a matter of it is totally different outlook on life that Australians have. Australia is a very rich country, as you know. It has raw materials. It doesn't have a major debt, and everyone is relaxed in what they do. That doesn't mean to say that they don't that they are not allowed to, or they don't get into personal development. Of course they do, but it's a totally different atmosphere.
So maybe in Australia we could say that it's not that one is necessarily better than the other, but the cost of starting and maybe failing is less. So it gives there's more incentive for people to try different things. And if you fail, it's not the end of the world. It's just that you get up there and you try again, because it's easier to try again. Yeah.
Exactly. And in Holland, when you commit yourself, particularly when there's some subsidy involved, it all becomes a lot more serious. I'm not quite sure what it is in Canada. I know St. John's a little bit because in my time with MARIN, we did a number of projects with the Royal Canadian Navy. So I know Canada is because of that much closer to the Netherlands when it comes to culture.
No, I was just also commenting, saying that that's true that here in Europe, it is so we don't have this mindset of entrepreneurship, because the cost of entrepreneurship, if you fail, it's high for society. So everybody is gonna see that, well, you tried and you didn't succeed. But in other countries like maybe the US or Australia, maybe they are like more entrepreneurs. You were saying that they were not lazy, Peter. But they have this culture that they are very approachable and also close people, the closeness to speak to them. And I also find interesting that I think it is one of the countries, maybe with the US, that they have less holidays during the year, right? So here in Europe, we have like 4 or 6 weeks. Well, I don't have that, but many people has these 4 or 6 weeks. In Canada, I'm not sure, Winston, about you, but I think in the US it's like 2, and in Australia maybe it is only 1 or something like this. So they're also very focusing on working as well. But yeah, just confirming this, I think that there are some other cultures that they give more value to entrepreneurship. And if you try, it doesn't work. So at least you tried, and people give value to that, and then they push you to try again. And that's a good culture. Yep.
So something that you said that sparked your interest to go to the Netherlands, was that the Alan Payne lecture?
No, that came second. But let me backtrack a little bit. At a small age, I knew I wanted to become a naval architect. I think I was about something like 14 or 15 when that became obvious. My father was involved in shipbuilding. My grandfather was involved in shipbuilding, and I was fed up with models, physically models of ships that were being built in the Netherlands. And so that choice was obvious. Now, at that particular time, there was only a part-time bachelor course in naval architecture in Australia, in all of Australia. So I enrolled, and I found a job elsewhere to provide some money to be able to do the study. But when I realized it would take 8 years to finish this particular bachelor course, I quickly looked around about options. And then one day there was this lecture by, I'll never forget it, John Tuft. He was a lecturer at the university in the Department of Mechanical Engineering. And we were discussing propulsion, the screw propulsion specifically, and the Wageningen B-screw series, which you probably both are aware of. Those particular charts have been used for maybe more than 50 years to design. Yes, still using them. A basic propeller, and then I asked him afterwards. I said, "Well, what do you know anything about education in naval architecture in the Netherlands? Because I can still speak Dutch, and if that promises much more of a education, then I would select to go back to the Netherlands." And he said, yes, the Delft University of Technology, besides MARIN, which then was called the Netherlands Ship Model Basin, NSMB, offer a great program, and we look at the program in the syllabus frequently. And I remember the next Saturday when we were having breakfast with mum and dad and my brother and sister in Australia, I said, "Hey, you guys, I want to go back to Holland."
Wow.
Well, as you can imagine, having lived there for about 12, 13 years, that was quite a bit of a shock. But as it happened, my mum was homesick once again, because she had just been visited by her parents, who had stayed about 3 months. She was homesick and ready to go back to Holland. And my sister had a relationship with an Australian guy, which had just broke up. She was ready to do something else. So the decision was quickly made, and we went back to Holland, and I enrolled at Delft University at the first opportunity.
So what about that Alan Payne lecture? That had a fairly big influence on you. What was it about that evening that sort of lit the spark?
I lived in Mosman, which was close to the DY Sailing Yacht Club, and there was on the lectures at the university were 4 days, and Friday was there were no lectures. So I was reading in the newspaper that Alan Payne, whom I had heard of, was to present a paper on the America's Cup and the America's Cup design and the America's Cup yachts. And I remember discovering that pretty late. So I rushed out, drove to the yacht club, but I wasn't allowed entry because I wasn't wearing a tie.
Times have changed.
How times have changed. So fortunately, we lived quite close, and so I was back within a quarter of an hour. Alan had started his. I got to know Alan very well afterwards, by the way. Alan had started his lecture. It was fantastic. He has a gift for telling, presenting a paper, and he dealt with the details of yacht design, getting that simple edge which would allow you to be a little bit faster than the opposition. The way the New Yacht Club had held on to the cup since 1851 and had never been lost. The US New Yacht Club had never lost to a challenging nation before. It all amounted to so much, and I had learned sailing by then, of course, because the Balmoral Sailing Club close by, of which I was a member, I was sailing in all sorts of boats. So there was this basic love for sailing yachts there already, but this really cinched it. This really captured my ambition.
So at MARIN, you developed the first analytical method for cavitation on foils and propellers. Did you realize, at the time, how sort of groundbreaking that work would be?
No. The fact is that when I, on my very first day at the towing tank, Van Maanen sort of talked to me, and he said, we've had a scientist work here on cavitation on foils. MARIN possessed a big cavitation tunnel, and here's his data. So he gave me a pile about that thick with results, which I had to go through. And he said to me, what you need to do is, if at all possible, come up with a predictor for cavitation on foils. The type of cavitation, the extent of cavitation. And I worked hard, and the thesis took about 9 months, 10 months to do, and I succeeded in developing this basic computer program. And the next step, which involved my Ph.D, was to do the same for propellers, screw propellers, in actual flow conditions. So not in a free stream, but in an actual wake a vessel would leave behind. And that took much longer, 3 years or so. But again, I was successful. I wrote my thesis, and I believe that MARIN used that particular program for years and years and years until CFD made its entry. And then, of course, the cavitation prediction models in CFD initially weren't very good. They became quite reasonable towards the end. So my predictor model as a program was used for a long time with MARIN, long after I left.
So then the things that you were doing in hydrodynamics, did they carry over directly into yacht racing design?
No, not at all. And not sailing yacht, not the sailing yacht, no, but it did, of course, for motor yachts. In those years, there was this enormous build-up of the power transported to the propeller. There were ships being built with 50 megawatts of power on a single propeller. And if you can remember Sir Charles Parson in the end having to use 12 propellers on 4 shafts to be able to get to his 30 knots, the whole field of ship propulsion had evolved, and we were successfully designing propellers for that sort of power levels in an actual wake field. So taking into consideration the wave peak behind shafts and behind brackets, that was quite something. There was a lot of vibration on those ships, mind you, and they wouldn't. Cruise liners wouldn't accept that sort of vibration behavior, but it was used. Those sort of power levels were used constantly on well-known ships that were sailing for well-known ship owners.
So if we follow up now, so we were discussing your time in the university, MARIN, and now I think it comes the moment when we are already starting about to talk about the America's Cup 1983, and this is something, the topic that I guess that you have been asked many times since then. So this is a very interesting topic as well for us. So you've been in charge of the team who designed the inverted keel that was behind the great success you have within the team, and you won the Cup for Australia after many years of the US having the Cup. So how was that moment when you realized that, well, we have this is something very big, we have something that it is not nobody has thought about that maybe in the past, nobody knows about that, and we can win the America's Cup for Australia. Can you explain a little how was that moment and the feelings you had at that moment?
I decided as a hobby to develop a velocity prediction program. You know, that term wasn't really used as much in those days, but I visited MIT around about that time and spoke to Jay Kerwin, professor there, and he was also looking at the possibility of developing a computer model for predicting the performance of sailing yachts. Sailing yachts were his love as well. So a yacht sailing at heel and at leeway was predicting all that was his aim. And so not having the MARIN is a commercial institute. Okay, that small budget was always available for novel ideas. So I went to Dick Vermaan and I said, well, I want to make a mathematical model for predicting the performance of sailing yachts. And he said, well, we haven't done anything of that nature since the war. During the Second World War, the Germans occupied the institute and basically let the personnel do whatever they wanted to do, as long as they didn't sort of sabotage anything. And in those days, sailing yacht models were being built and tested there. But since then, nothing had been done in the way of instrumentation, software development, extrapolation to the full scale. And so when I went to talk to him about what I wanted to do, he said, okay, fine, I'll give you a small budget where you can work from, but basically it's not much, and if it's not enough, then you'll have to make ends meet. And so what I did, and this is actually what happened, I spent 3 years in the evening and on the weekends developing this particular program. Part of the work was, of course, establishing a good correlation with full-scale data. Kerwin at MIT helped me with some papers covering the measurement, the tension in all the stays on board of Weatherly, which was a 12-meter yacht, which he gave to me, for which I was very appreciative. So I was able to establish a good correlation with the actual thing. That all happened in the period 1977 to 1979. In 1979, I was convinced that I had a good predictor. And so what did I do? I looked at the situation. The situation was that Australia had challenged for the America's Cup 4 times already and failed. Mm-hmm. But I knew many of the guys on the team. So I wrote a letter to Alan Bond. He was the big billionaire in those days who provided all of the money. And I wrote him what I was able to do. And I think it was only a matter of days or maybe 1 or 2 weeks before he replied and said, come over, I want to talk to you. So I took a trip to Sydney, talked to him, and I think I convinced him what he needed to do, which was A, use the predictor for coming up with a better keel shape, because Australian yachts were losing sailing to windward. Downwind everything was okay, but to windward was always lacking. And the use of big models for testing. I mean, model testing for America's Cup yachts were what, only a meter or meter and a half, and as you probably know, there's a lot of scale effect involved. so you don't get the boundary layer doing what it's supposed to do. And so he said to me, Alan said to me, all right, well, look, there's a few things I've got to do, and I'll have someone contact you later on. Nothing happened. And I stood by for 2 years waiting for the imaginary phone call, and nothing happened until on a Saturday morning, I was called by Ben Lexon. Ben Lexon was, let us say, the designer to be. He said, Peter, I'm in Amsterdam and I want to see your facilities in Wageningen. I said, okay, do you realize it's a Saturday? I said, yeah, I fully realize it's a Saturday. So I invited him over and I showed him all of the 8 laboratories we had, and he was really enthusiastic. So he said to me, make a proposal covering 2 approaches to the whole design thing. One is improving keel design when the keel is a sort of a standard looking keel, and then we'll reserve some money for another way of attacking the problem, which I can't at the moment define, but we'll talk about that when I get there. And so that's what happened. I'll cut the story short a little bit. I made my proposal, it was accepted. In fact, the money I asked for was added to. I went to Dick van Maan and I said, well, look, we have this money for this particular project, but there's a lot of things we have to do and provide money for ourselves, which is a new dynamometer for testing at Hill and Leeway, which wasn't available anymore. Anyway, it was all set and go. And I was given charge. I was put in charge of this novel approach, an upside down keel, a keel which had that sort of sweep back, a keel which had that sort of sweep back, and a keel that basically had no sweep back and was basically this. And then I had heard that the National Aerospace Laboratory in Amsterdam had a new computer program for analyzing lift and drag of airplane configurations. And I had met Joop Sloof. Joop Sloof is an aerodynamicist. We were both seconded to the Netherlands Navy working group studying the merits of high speed for future naval ships. And that's where I met Joop, and we became friends. And he said, well, look, I can analyze these 4 shapes. I have to tweak the code a little bit, but I'd be happy to run a program for them. And that's what happened. He became a subcontractor. He didn't ask much money. And it became quite apparent that the upside down keel was a lot better. Well, we'll not say a lot, but in the context of performance in the America's Cup, where every second counts, it was good enough. So, and then Joop said one more thing, which really clinched it all. He said, well, look, are you aware of the fact that we now have winglets? This was Joop's idea, not mine. And we had a big meeting with Ben Lexon sitting in, and he explained that Richard Whitcomb from NASA, the NACA it was in those days, I think, who had taken a patent on the winglet concept. As it happened, the National Aerospace Laboratory in Amsterdam had just completed sort of a feasibility study on winglets, and they were surprised at the enormous reduction in induced drag. Induced drag is brought about by the swirl at the bottom of a lifting surface. For aeroplanes, it makes the wings about 7% better. But when you get to low aspect ratios, such as the keels of 12 meters, which were enormously long and not very high, it mounted to 30%. So we had a 30% reduction in induced drag.
Yeah.
So that's what happened. We tested it. The first attempts were not very good. The keel was much too big. And in the end, when we sized down the keel size itself and the winglets to a mere to a mere, what shall I say, 2/3 of the wetted area of the standard sort of keel. I knew the performance was there to win the America's Cup. In my own calculations, I found things like 2 minutes, 2.5 minutes of gain over a triangle Olympic course, and which was huge in those days. It was absolutely huge. So if you could sail as good as the Americans could, and if you had the sails as good as the Americans had, we could do it, and that proved to be the case. The challenge in '83 involved Canada, Italy, 2 teams from Australia, France, Sweden. So there were something like 7 or 8 countries that Alan Bond's team had to beat before becoming the challenger, able to face the American yacht.
And I wanted also to ask you, Peter. Then you won. The Australia 2 won, and then it started this polemic around about nationalities. That at that time, so all the team had to have like the Australian pedigree or nationality behind the concept, but they worked somehow with the Netherlands and with you, and everything started to go a little astray. So how it was for you? How you felt at that time?
Okay, well, the Americans had, of course, had seen Australia beat all the other yachts to become the challenger. I think Australia 2 only lost 1 race. That was to Azzurra. Azzurra was the Italian challenger, and so it had something like a 35-1 win over all of the other challengers. So the new yacht club became very nervous at perhaps losing the America's Cup. And so they formed a committee, the America's Cup Committee it was called, to look at every possibility for disqualification. Impossible. So, but they quickly decided to challenge the whole concept, which is that when Australia 2 heels, its maximum draft increases. The winglets having been shaped like this, so when you do that, the bottom tip of that particular winglet sort of is in excess of what you're allowed according to the 12-meter design rule. So that's where the first challenge came from. But then, as it happened, the IYRU, the International Yacht Racing Union, then called, I think it's called sailing.com or something. Anyway, the International Yacht Racing Union had by chance okayed the whole concept. So the chief measurer had okayed the concept the year before. So that challenge was quite quickly set aside as being of no consequence. But then they realized that, or they were told, I think they were told, I still think that to this day, that the Dutch had a lot to do with the keel and also the hull. We also changed the design of the hull. The aft 40% was refaired, modified quite extensively. And so they sent as it happened, the designer of the American yacht Victory was a Dutchman with an American passport, Johan Valentine, his name was. So he linked up with some of his family members, also involved in yachts and yacht design, and they made a thorough research in the Netherlands of what happened in 1981 when we designed the keel. And for some reason that I still haven't been able to find out today, is that they've got to know quite a bit about what we did, what we individually did. I'll backtrack a little bit. MARIN, myself, and a colleague, we designed the software system on board of the yacht as well. So we had a telemetry, we say in Dutch.
Okay, yep. Telemetry, yeah.
Yeah, okay. So I was on the tender with my computer in every race, and I would be picking up the signal that was being sent by Australia 2 and we were doing rudder angle, we were doing apparent wind angle, true wind angle, heel. We're doing something like 15 different signals, and I would be analyzing that in the crew house every day, every evening. And I would, during dinner, I would stand up and I would say, well, look, this is what we did today. We were off the mark quite a bit in VMG, and gave the guys a feeling for what they had achieved. I should say, I took 10 days off from Newport. This has all happened in Newport. I took 10 days off in Newport, and I spent a number of those at MARIN, because there were some ongoing projects. And it so happened that during the days I was there, we were visited by a lawyer with an affidavit that he wanted me to sign. The affidavit said that I, Peter van Oossanen, designed the keel and the hull and etc., etc., etc. And I said to him, well, look, I can't sign that. Even if it were true, I can't say it. I can't say that. The whole of Australia would be after my blood. Yeah. So anyway, he said, Peter, Richard Latham was his name. He said, Peter, I understand fully and forget all about it. I objected to this sort of way where we're trying to disqualify you guys. And so he went away, and they had I got to know him quite well afterwards. He was a fantastic guy. We had a click with him. But anyway, the difficulties started arising when the television channels got wind of this particular situation, and they hounded me to goodness to I don't know where, trying to have me own up to the situation. And look, up to this day, I'm a bit ashamed of how I approached it. I lied at least 20 times about Ben Lexing having designed it all, and I had nothing to do with it. So much so that that Martin Peterson, he's professor at MIT University in Houston, Texas, a friend. He's an expert in ethics, engineering ethics. And he said, look, I want to write a paper with you as co-author on the dilemma that you had to face and in fact had to lie about, because the boat would have been disqualified, the team would have been disqualified. All of Australia was watching those races during the night. I mean, you're talking about millions and millions of people. The Prime Minister said at one stage, when the cup had been won by Australia, said, every boss that wants his people to come in today to work is a bum.
Okay.
Historic words. So this was the scene I ended up in. So Martin Peterson, he said to me, this is a dilemma like I haven't ever encountered before, and I want to write a paper about it, which he did. And I haven't had anyone yet that has approached me and said, you shouldn't have done what you did. I mean, there was no option.
Yeah.
And basically that was Martin's, well, there was an option, and that was for me not to answer any of the questions and just to refer the matter to Warren Jones. Warren Jones was the director of the Australian Challenge. And I could have maybe done that, but
this is fascinating. Also interesting enough. So Navalapp started. I wanted to create a VPP myself, a software, the VPP. So well, the difference between you and me is you were a pioneer on that. When I tried to do it, there were already 1,000 of them already available. But this is how I started Navalapp as well. So that I found that it was very interesting. So as I say, Peter, this is when I think of myself, if should I have being a naval architect from the beginning and so on, this is the life I would have to live myself, this kind of adventures and successes and problems and solving and so on. So it is really, really interesting.
I noticed that you wanted me to say something about the 5 volumes and how what they contain.
So about the book. So this is why we entered into contact first. So I knew you already by name, but when I knew about the books, the quality of the books and how good they are, so I was really interested in I don't remember exactly how we get into contact. And by the way, I'm very glad that about your openness or always kindness, so that it has been very, very, let's say, very easy to talk to you and discuss with you. So I thank you very much for that. So when you retire, why did you want to make this and write about these books? What was the idea?
Right. Okay. Well, I retired in 2013. My son, who's now running the business, was ready. Was ready to take my place. And I'm not one to sit reading a newspaper and drinking a cup of coffee all day or watching TV. So I decided to write, and basically, of course, about sailing yachts, and so I set up a whole plan, really involving something like 7 or 8 books initially. But what I wanted to do was I wanted to leave something behind. Yep, there we are. I wanted to leave something behind, a sort of a legacy. Over the years, I had kept a list of things that I wanted to sort out over the when I was retiring.
Mm-hmm.
So yes, it's something like leaving a legacy, but also leaving a textbook for students, for naval architects professionally, and basically sailors that are really interested in their boat and that have a sort of sufficient mathematical and physical grasp of things.
I think that push to make something for the next generation is a really positive way. So a positive thing. So I can tell you that when I was starting and looking for information about all of this that you are writing, so nothing, I didn't find anything that I can find now in your books. And I think now they are for me like personally the Bible for the hydrodynamics of sailing boats. I think many generations are gonna be grateful for that. And on the other side, well, I don't think there's nobody that he doesn't want to make something also, that to be remembered. So this is like all of us, we would like also to be remembered for positive things. And I think this idea of making the books is clearly something that are very positive.
One important aspect that I wanted to cover in volume 6 was stability, transverse, longitudinal, and directional stability. You see, the situation is as follows. In motor yacht design, the angle of vanishing stability is a mere 35 degrees, for example, depending on what code you're doing the design work to. And in sailing yachts, I would hope that all sailing yachts would have an angle of vanishing stability at least 110, 120 degrees. And yet we are faced with, and don't forget, I was chairman of an ISO working group that developed the important ISO 12217 codes. And I was continually faced by, particularly, I won't mention any names, but particularly faced by groups that would come to the meetings. And sometimes we would have some meetings with 40, 50 people around the table that were pressurizing me and others to come up with a bare set of minimum requirements, which will one day, if not already, will result in catastrophes. So I had this enormous documentation on 12217-1-2-3, and I wanted to bring that in order, and I wanted to cover it from my perspective, which is that all these cases should comply with another set of rules, and I would have wanted to do something in the way of developing new rules. When we had COVID, social life in Holland was quite restricted, maybe in other countries as well.
Mhm.
And I wanted to do something else other than the science of sailing. And so, as an experiment, I decided to try and write something in fiction.
Mhm.
And so, thinking about a plot, this and that, and I found to my surprise that it came easily. It was fantastic in doing. Had to have a plot to develop it and to have characters to develop the characters and their interplay was something that that really gripped me. I can remember back in high school in Australia when I would write an essay, it would all my essays would always end up in the school newsletter. So I was aware of the fact that I was able to write in English. I still don't know how to write in Dutch, by the way. I still make all sorts of mistakes, but my English was good, and the words came rolling out of my laptop just like that. It took me 15 weeks to write 450 pages for my first novel. Mind you, it was the first draft, but it was there, and it was basically it hasn't changed all that much since then.
Mhm.
And I continued with that, and now I have four books with Atmosphere publishers in the United States, and that kept me very busy because apart from the manuscript and going through developmental editing and going through proof
Yep.
copies, and you know what I mean.
Yeah. With which books are you having more success, Peter? With the science of sailing or the fiction writing?
I think in the end, the science of sailing books will have given me more satisfaction.
By the time when you were studying, it was in the 60s, I guess, right? Or early 70s. So you were studying naval architecture, and today maybe you are a little disconnected of what the students are doing today. I don't know, but how are you feeling? How their study has changed over the years? Yeah. Are they studying the same things that what it is really necessary for them to become naval architects, or what are your opinion about the programs today?
And maybe the best way to address that is to tell you of what happens in an America's Cup design team.
Okay.
In my time when I was involved in America's Cup yacht design, there would always be one or two, maybe even three or four naval architects involved. They would take the major decisions. They would have their office people make the calculations and drawings, and they were really in charge of of the work going on. Nowadays, the America's Cup teams will hire maybe 30 or 40 people that know how to run CFD. And those people have knowledge about CFD, but they don't know what they're calculating. They don't know. They look at the answers and they can address if one is better than the other. They don't have enough knowledge of the physics involved. That's my main point. My main point is that we're now educating a lot of people in how to use codes of all sorts of codes, and for them to answer the question of, for example, stability, is that enough or not enough? But the underlying physics is being forgotten. What I should say in support of that is that if you look at the history of naval architecture, and you look at, I have in my bookcase here, I have something like 50 books that are published by the Royal Institution of Naval Architects, and something like 50 books published by the Society of Naval Architects and Marine Engineers in the United States. Mm-hmm. And those papers were all written by people that understood their field in great detail, and discussions about design, naval architecture, marine engineering even, were not based on the results of some code. They were discussions of actual things that happen and why they happen. People running the curriculum of some of the universities are aware of this, and I think the better universities, we should exempt the better universities from this category. They run a proper curriculum with emphasis on mathematics and physics, and hydrodynamics and aerodynamics. And I'm not talking about the codes to get answers from, but I'm talking about what our peers or our previous naval architects and scientists have developed to be able to understand. So there is, so my complaint really is that there is this general shift in what students are being taught these days, and at the cost of not teaching them the knowledge that we really have. There is a lot of knowledge that those people have developed over the years. I can mention a number of key papers that were that discuss these things. Now, I'm not criticizing you, Pablo. I think what you are doing is an add-on to the curriculum that we see being run by naval architecture schools these days. You're giving your members, your people, the possibility of actually coming to grips with some of the concepts in terms of quantitative analysis of what they're doing. So in fact, what you're doing is an in-depth program, and which added to the mathematical and the physics of it all is very worthwhile.
Yeah.
But I do criticize universities, at least in our country, with the exception of Delft, where in Delft the first 2 years you enroll are spent entirely on theoretical mathematics and theoretical physics, and you start doing naval architecture studies in the third year. Now, that when I discovered that when I was enrolled in Delft, that was a bit of a disappointment. But the maths and the physics involved has to be. You've got to have you've got to know what flow separation is. You've got to know what laminar flow is, what turbulent flow is. You've got to know two sails can interact. You've got to be able to argue why a particular setting of a Genoa with a mainsail, why that gives the results that you see when you run a CFD code. Why does a screw propeller show more navigation, more cavitation in more uniform flow than in a wake flow? If you don't address that at its roots, then you don't really, you're not preparing the future naval architect in the way it should be done. That's maybe it's harsh to hear me out on that in that way, but that's what I feel.
But I think it's completely right. At least also from my perspective. So what we are trying to do in Navalapp, it is where we are teaching tools, but we want that the people knows how things work so that they input the inputs that they need to run these tools and also learn the results. But we see actually that those courses that are more fundamentally linked to physics or mathematics are the course that people that like the less. So they want to jump already, in those courses that you start to design. But yeah, maybe you can start to design something that is going to be tangible during some time. But if you really want to end in something which is meaningful, so you have to go back to the physics and maths, because it is not like a modeling is going to make the difference. Modeling, so you can create a really nice model, but then it's going to sink. So you need this. But people, my experience with Navalapp is people likes to go to jump to those designing courses already, and they are trying to skip the basics of mathematics and physics, which is completely okay if they realize later that now they want to develop their path in that direction, but now they accept to go back and learn all the underlying physics, so now they can make something or design something that is going to work.
The respect that I have for what you're doing is also based on the fact that you have 4,500 members, I believe. Mm-hmm. That you're actually having your people, having your students become aware of naval architecture, of designing sailing yachts specifically. And I've been involved, for example, in this country, in discussions with people at the university of how do we get young people interested in our field of work. And that's always been a bit of a problem, but your approach has really been very, very good in the sense that the people that run your course, that are involved in your courses, get a good appreciation of what our field is, what naval architecture can be.
We want to make those accessible for and affordable for many people around the world. And also, I have to say, as you said, you mentioned also before, so in my family also runs the sea. So my father and grandfather, they were both captains in the merchant shipping industry as well, and a lot of people working at sea as well. And maybe that was also even in my mind without knowing. So it's something that also pushed me on that direction. But I'm really passionate about the naval architects and what you are guys doing. I'm myself a industrial engineer, but I found my career or my passion later in life. So that's why I'm very happy to be here now.
Taking just a few minutes now to look forward. You've had a long and distinguished career, and you've seen a lot of change over that career. So if you were to sort of project forward, what would you say is going to be some of the driving factors in the future of naval architecture and design, and maybe speak a little bit about innovation?
Yeah. Well, it's the premise that we're facing a climate change. We have no option other than to lessen our footprint on Earth, our individual footprints, if you like. Recently, I was a member of a group discussing the ethical aspects of one person owning a 100-meter motor yacht and sailing in it, etc., etc., etc. So I think if the premise that we are in a climate change, I would say energy efficiency and sustainability is what needs our top priority. So I've written down here in answer to that question. I said yes, we need to decarbonize the way we live, and our footprint on Earth is too great. We need to look at that seriously. And for example, my company has a program. Luckily, we earn enough money to be able to actually finance projects ourselves. But we're looking at, together with MARIN, actually, we're looking at alternative fuels, the whole range of alternative fuels, including nuclear power, and ways of making our business responsible. And I would argue with anyone that sees it differently.
I would like also to add, so it is interesting. So we are in a situation where things that we thought before that it were not even possible for yachts or for bigger, merchant ships like a nuclear. So now it is or back in the table as well. So it shows as well how in the limit we are, how little answers to the problems we have today, or answers that can develop very quickly to revert the situation. So we need to bring all kind of possibilities into the table now, because everything is open. We want to achieve the levels of emissions we want to achieve it by 2050 and so on. So it is very interesting to see now, and you mentioned also, Peter, before, that even nuclear, it is on the table for commercial shipping and pleasure shipping, so super yachts. So this is interesting. Yeah.
So, Peter, when I'm teaching my own students, I often say that, we are very fortunate to be where we are in terms of the maturity of engineering and design and naval architecture in general. And we stand on the shoulder of giants. And of course, you're one of the giants that we stand on the shoulders of. So, coming from you, I'm just wondering if you might have some some advice for young naval architects and young ship designers and yacht designers?
It's not an easy question to answer, but naval architecture is going in two directions, as I see it. There is the direction where young people are happy in running the codes and doing everything that is necessary to come up with a design. And there are those who are looking more towards new developments, inventiveness. You see, a CFD code will never give you an answer to a question of how can we improve something or how can we invent something to do something else. It asks for a total geometry that has to be input into the into the code. But where does this geometry come from? It would need to come from someone that is understanding the hydrodynamics of it all. In the case of CFD that we use, and having formulated a question based on analytical, or if you like, a proper sense of the problem, which distinguishes itself from the other approach. I've always looked at this from a point of view of education. People only interested in a bachelor's degrees. We have, I think, in this country, we have something like 6 schools offering a bachelor's degree in naval architecture. We have, we pick a number of these people to work with us, and we observe what we give them a subject to study, and we do the same with someone that has developed in Delft. Delft is the only real top university doing presenting naval architecture courses, and you see the difference immediately. There's this, there might be this woman who has pursued a Delft type of education, who will actually come to talk to you, to me, or to my son Perry, and say, well, look, I've thought about this problem. What would you think about doing this or doing that? That would need to lead to something positive. And then, of course, we have the guy who comes in and says, have you got a manual on CFD, the code I'm running? Now, so there's this difference in level. There is this difference in how to approach the whole subject. AI is the same. AI will give you an answer on something, but can never come up with something inventive. If you were to ask GPT, for example, what is the best hull, all that it will do is it will try to discover websites that will have, say, energy numbers on a number of different hull forms and present them to you, but it won't come up with a new hull form.
Yeah, this is very interesting, Peter, what you are touching. That reminds me, we have a course on artificial intelligence, also machine learning in Navalapp. And I think what you're saying about ChatGPT, so those are as bad as the training program that they have gone through, actually, because what they need is to have a training data that is reliable, so it is a good one, and need thousands of this data so that they can infer the results for a different situation. And on this course, what we are teaching the students is we are using the MIT whole data set. I think there are 30,000 different holes with different geometries, and all the results which are correct. We are training the AI, and then we are asking the AI about a new hull shapes and everything. And based on that, which is a good input, it is not something that it is inventing. So somebody has to sit down and make all these results. So thanks to that, so at the end, so there is a quite good result as well. But I agree with you. So that ChatGPT and some of the tools so far, they are not trained enough because maybe there are not data enough to train them. But it could be that in the future, we are going to see more and more. And what you are doing, and you're saying what you are doing, and Oossanen Naval Architecture is also going in this direction, and is also remarkable. Peter, now we have like 4 questions. And the questions are prepared to be answered in one word, if possible, or 3 maximum. Let's see how it works. So this is why it is they are called Quickfire personal round. So we go like this. Well, feel free to answer as you want. So first question is if you were starting out today, what problem in naval architecture would you want to solve?
I've just changed the question a little bit.
Okay.
Because you have here, what's one innovation in yacht design you wish you had invented?
Okay.
And that really that caused me to ponder quite a bit. But I think I would have loved to have been the first to utilize foiling in a stable way in our hulls, in our fast hulls. Foiling at the moment is still a bit of a dangerous thing. I can't imagine anyone just sitting at the rudder and having the boat foil properly. So that's what I would have liked to have done.
Okay.
Shall I?
Yeah. Go ahead. Yeah.
Okay. Shall I take the next one?
Okay. Yes.
The favorite yacht you've designed. Okay, I had to think about that one pretty hard as well, but I think in the end that's pretty clear. I was part of. I worked together with Bill Joy in the design of Ethereal in 2009. Ethereal, or Bill Joy rather, is co-founder of Sun Microsystems, and when he sold his share of the business, he became very, very wealthy, and he engaged Hoosman Yacht, the builder, the prima lux builder in the Netherlands for sailing yachts, and he asked me to work alongside him, not alongside the designer or the yard, but work alongside him. And we developed a hybrid propulsion system. And I'm talking about 2009 now. A hybrid propulsion system, allowing him to use electric propulsion in places where he simply wanted to maybe sneak out of a harbour somewhere, I don't know. But he was set on that. Energy recovery. He has 2 propellers on the hull, and he is able to feather them, but he's also able then to, when he's running on an engine, to have them in this in an appropriate pitch situation, and he generates he charges his batteries. Besides that, he's a great guy. I had a click with him, and I still have very fond memories. But then, of course, there are something like we in our big meeting room in the office, we have a timeline on the walls showing every yacht that we've designed, or every ship, I should say, because there are also some commercial ships there. And it's a gigantic. It's at least 150, if not more, yachts and ships that we've designed.
So, what do you hope for your legacy will be?
Those 5 science of sailing books gather a bit more momentum, take up a bit more of an effective position in the literature. We keep selling books, but not at a rate at which we'll obtain that. So we need a bit of a push in selling them. But I hope that was my main legacy, that some of the methods described in those books, methods that have never been developed before, and methods that will give designers a better sense of, say, stability, propulsion, and of course the fictional books I'm writing basically because I love doing it. I don't expect much from them at all, but it is what it is.
Is there any sailing in your fiction books, or not touching any sailing or naval architecture things or themes?
Well, hang on. My last book starts with the Monaco Yacht Show.
Okay. You cannot disconnect at all from it. Thank you, Peter, very much. So as I told you, it's been a real pleasure to talk to you. And since we have been in contact, I always admire your kindness, closeness, and always approachable that you are. So it has been touched me. And the conversation here only reinforced that. And you have a lot of stories that, as I told you, so they are very inspiring for me, even if I'm already old. But there will be very inspiring for many people maybe starting their career. So I thank you very much for your time and for explaining all these things for us and sharing this time with us. that brings us to the end of today's episode.
Yes.
I want to give a big thank to you, Peter, for sharing such valuable insight and stories. It's been a real pleasure having you with us. And thank you as well to Winston Pym, my co-host, for being part of this conversation and for making sure everything behind the scenes runs so smoothly. Okay. And to everyone watching or listening, thank you for joining us. We hope you enjoyed this discussion as much as we did. If you'd like to learn more about yacht design, naval architecture, or ocean engineering, you can visit us at navalapp.com. And don't forget to like, share, or subscribe if you'd like to stay updated on future episodes. So until next time, take care and fair winds to all of you. Bye.
Thank you. Thank you very much.